Welcome everybody back to another Secure Ideas Professionally Evil webinar. It's great to have everybody. We see people still coming in, so we'll give you a few seconds to get started. While we're doing that, I just want to call attention to a couple of things. If you have questions, if you want to chat, or just have any feedback as we go, feel free to use the chat over on the side. There's the public chat. You can also use the presenters chat or the private chat if you need to send something directly to the hosts. If you have questions about your environment, something specific to your area, feel free to use that and we'll kind of anonymize it as we answer the question. Just remember this is being recorded. So, don't put out there personal details, corporate details, anything like that you don't want to be shared in the future. We usually upload these to YouTube after a few days. So it's out there for review. The slides are available. Like I said, the video will be available on YouTube later if you want to send that out. Also, if you need a CPE certificate after this is over, there's a message in the chat there. You can just send an email to education@securideas.com and we will forward those out to everybody. If you need those, unfortunately, the system doesn't do it automatically, but we'd like to help you out if we can there. Anything for a few more CPEs, right? One last quick announcement before we get started. So I'm posting a link here, securideas.com/webcast. Obviously, you found this webcast, whether you found it on our website or through social media or whatever. But we have a list of other ones coming up. I think our list, I'm looking here, we go down into October, and then we've got several more scheduled for November and December that we'll be pulling in as well. So you won't want to miss those. In September, we've got one on navigating cloud security with critical controls. And so we're going to walk through, I believe it's AWS, Azure, GCP, and talk about some of the critical controls for cloud security that you definitely want to make sure that you've got implemented. And then on September 22nd, we're going to have a panel discussion talking about ransomware and alternatives to, maybe not alternatives, but options for minimizing the risk associated with ransomware. A lot of people think, hey, I've got backups, I'm good, right? We're going to talk about, all right, is that good enough? And what are some other things you should be considering to make sure that, you're not staying awake at night, stressing out about the potential for ransomware. So with that, it looks like we've got a bunch more people that have joined in. It's a couple minutes after the hour. So let's go ahead and get started. I want to introduce our host for today, our presenter, Cory Sabol. He's one of our security consultants, senior security consultant. He's actually on my team. We here at Secure Ideas, we've got our consultants split into a couple different teams. So Cory and I work closely together. I can honestly say Cory knows more about Kubernetes and container security in general than anybody I know. He's taught several classes. He's written and taught some classes for us on Kubernetes security. In fact, one of those is coming up soon, right, Cory?
Yeah. We've got a couple of different variants of it coming up kind of soon.
Awesome. So I'll post a link to that in the chat here in a few minutes as well. You'll definitely want to follow up if you have responsibilities around containers or Kubernetes. You'll want to follow that up. Today's webinar is going to be a little bit more of a high level. We call it a bird's eye view. Cory's going to walk us through understanding, real quickly what Kubernetes is, kind of a quick level set. And then we're going to dive into understanding some of the things you need to understand and be aware of, regardless of what level of responsibility you have for your Kubernetes environment. So with that, Cory, I will hand it over to you. And if you have questions, if you're just joining, feel free to throw them in the chat and we'll go from there.
Yeah, cool. Thank you, Nathan. So this is bird's eye view, navigating the landscape of Kubernetes security, right? And so bird's eye view, we're going to be looking at this from pretty high up, right? So get that good overview of things. And in the slides, there's some contact information for me as well. If you, want to reach out after this, after this webinar, you have, questions or anything like that, or you're interested in trainings or, the kind of work that we do and offer, you can definitely reach out to me or Nathan. That's in there. But we'll go ahead and just dive into the agenda. So we're going to talk a little bit about some background info. Like Nathan said, we'll kind of do a level set, clear up some terminology and talk about, just this is what Kubernetes is, right? This is what a container is, just so that that's clear as we kind of go through and talk about some of the actual security controls that you would want to be thinking about when you're, working with or responsible for, a Kubernetes deployment. So after that, then we'll look at those high-level security practices. We'll talk a little bit about some vulnerability detection solutions, right? Essentially ways that we could monitor our clusters for insecure configurations and vulnerabilities. And then we'll take a little bit of time to kind of dispel any sort of misunderstanding about the CIS Kubernetes benchmark. And what we'll see is the benchmark actually will cover a lot of overlap of what I think are the top kind of security concerns as well. But the Kubernetes benchmark does kind of it gets very detailed. And then we'll do a live demonstration where I'll just show you like a really quick scan using a tool called KubeBench, which will scan a Kubernetes cluster and evaluate it essentially against that CIS Kubernetes benchmark, right? So it's a good tool for checking to see, okay, is our deployment, in line with these benchmarks? All right, so the background info, we'll start out with just understanding containers really quickly. So what is a container, right? It's a word that's been thrown around a lot for a few years now, right? And often kind of gets a little confused with, like a virtual machine. Sometimes containers technically can be VMs, sometimes they're not. But the best definition that I've found is pulled from the Kubernetes website itself, which is a container is a lightweight and portable executable image that contains software and all of its dependencies, right? So it contains some piece of software that you want to run and also everything that's necessary for that software to run. They're generally lightweight. They provide various degrees of isolation, process isolation, network isolation, file system isolation, these sort of things. And they're intended to be reproducible. So that is, you specify the configuration using essentially infrastructure as code, right? So you have for Docker, for example, you would have a Docker file, right? So you can, in theory, take that Docker file and rebuild the image, and it should be the same every time. You can take the image and deploy it on different systems, and it should, in theory, run the same. And this is not super important for what we'll get into today, but just something to be aware of is most container runtimes, they actually share the kernel with the host system. So I'm actually teaching a class coming up on techniques for escaping containers. One of the big ones takes advantage of the fact that most container runtimes share the host with the kernel. So if there are vulnerabilities in the host operating system kernel, those vulnerabilities can be exploited from within a container. All right, so moving on, let's talk about container orchestration. All right, so this is what Kubernetes is. It's a container orchestrator. And a container orchestrator is a system that's responsible for the various aspects of managing complex containerized deployments, right? So that's the life cycle of the containers. That's how they get deployed and where they get deployed to. So within Kubernetes, that's things like which node should this container run on, right? How many of them should run? How long should it run? You have scaling. That's, right, again, how many should run. If we start to see resource issues in the number of containers we have running for some service, can we auto scale that out instead and then load balance across the new instances? These are typically really useful in complex CI/CD pipelines. And just like containers, they're kind of going to fall into the infrastructure as code category where, for example, with Kubernetes, you define everything using YAML files, right? These YAML config files. And the benefit of that is that it can be version controlled. You can run static analysis against it to catch issues before you deploy things. So that's very useful. And again, kind of just covered this in the last slide, right? Kubernetes is a container orchestration system. It's an open source one, right? And it provides all of those sort of services that we just discussed, right? The deployment, scaling, lifecycle management, things of that nature, logging, all that good stuff. Interesting side note is the word Kubernetes, apparently it comes from the Greek word for helmsman. And if you've messed with Kubernetes much, right, you know that they kind of have this nautical theme. Containerization sort of has this nautical theme going on, where Originally, Docker was called Moby, like the whale. And so it just sort of, the community that built up around all of this sort of, really took to that nautical theme. Even the Kubernetes logo is it's a ship wheel. Yeah, that is what the word means. Okay. So just some terminology that, I may mention while I'm talking about things, just to kind of level set the I guess understanding here, is cluster, right? So a cluster, you can think of, this is just a set of machines running containers. You have a node, which is a machine in the cluster. That could be a container itself. It could be a VM, or it could be a bare metal machine. Right? You have, with Kubernetes, you have the concept of a pod. That's a set of containers which are running within a cluster. You have a deployment. That's specifically a Kubernetes API object, which manages the replication of the application. So that manages like what image to use for the containers, how many of them should there be, where do they get deployed within the cluster, so on and so forth. You have the concept of a service, which is another API object that describes how to access those deployments, right? So you could deploy something to a Kubernetes cluster, but it's limited to the internal network of the cluster. So services are how we expose those internal applications, those containers, to the external network, so that users can access them, other systems can access them, that sort of thing. And then you have namespaces, which is one that I like to talk about a lot, because it's not really a security control, but it's something that a lot of security controls within Kubernetes sort of build off of. But this is a virtual cluster in the same physical cluster, so to speak. And this is where terms kind of get overloaded a little bit. But what I mean by virtual cluster is, if you take a bunch of resources inside of a Kubernetes cluster and you give them all the same namespace, then in terms of the way that those resources see things in Kubernetes, they see it as if they belong to that namespace, which is its own little cluster inside of the main cluster, so to speak. So it's a way of segmenting off workloads inside of your cluster. It's very useful. All right, so we covered that. Let's get into some of these high-level security best practices, right? What I think are some of the best practices for Kubernetes. So with Kubernetes, and really any containerization system, right? Whether it's Kubernetes or you're using what's another one? Docker Swarm. Most everything is moved just Kubernetes or some variant of Kubernetes at this point. But there was Apache Mesos at one point. I don't know how that project is doing. But all of these are using these container images, right? And as I mentioned before, like, what is a container? Well, it's a package that contains some software and all of its dependencies that are required for that software to run. And so it creates this execution environment for that main process. And images are, right, those are copies effectively of that execution environment. So you execute an image essentially, right? That's what you run when you run a container, you're running the image. So I know when, for example, I'm doing a penetration test on a Kubernetes cluster, if I am, one of the things I'd like to look at is, what base image does our client use in their cluster? Or if I manage to get a shell and I'm running commands within a container in their cluster, I check to see what tools are present in that image. And the point of that is from either like a config review standpoint or even pen testing standpoint. These images should only contain what is absolutely necessary for its software to run, right? So whatever the main process is intended to be, if it's a Django web server or something, right? The only tools that should be present in that image are the ones exactly necessary for that web server to run. And the reason for that is if there's additional tools in there, if a hacker, is able to run commands or execute code in that container, well, now there's additional tools and binaries there that can make it easier for them to, bypass restrictions and things of that nature. And also, right, using trusted base images. So this comes into the idea of vendoring your own images using a container image registry. And all of the big cloud providers, like they offer container image registries as a service. There are self-hostable registries. I think like JFrog Artifactory, for example, supports, hosting these images. And the point of forcing all of your deployments to use a trusted base image is that you can control that, right? It's dependency vendoring. Right? You have validated that baseline configuration. It is, it meets your criteria for being secure, has, the baseline of what you need for some deployment. And so you can trust, right, that it's not, compromised in the sense of if you have your developers just pulling whatever images they want to build their applications off of from public registries like Docker Hub, those images can potentially be backdoored, right? And they can contain malicious software and things of that nature. So it's very, very important to use these minimal trusted based images, right? And that actually goes a long way towards ensuring, your workloads are running securely, because it's sort of the foundation of things. It's also useful to use an image scanner to identify vulnerabilities, right? So it's possible to scan those images before they're running to identify potentially dangerous, configurations or vulnerable software that's installed, right? Detecting, potentially vulnerable, outdated software components, right? That are being used in your base image. You would want to then update those, right? So it's important to kind of have that hooked in as well. Again, a lot of the major cloud providers like AWS and Azure, their container registries do have some degree of image scanning capabilities built in. I don't know exactly what the extent is, but it is possible to have that, scan your images, and it, compares that against a list of, essentially compares that against a list of known, vulnerabilities. And then having that image scanning integrated into your CI/CD pipeline, right? Because building these base images is just sort of another part of the software development lifecycle. And so just like ideally when building like a web application, for example, ideally a company would vendor their dependencies so that developers are only able to use trusted approved dependencies. And they would integrate vulnerability scanning or static analysis, things of that. For example, with like Node.js, you do npm audit even. It's just like the bare minimum example. And that will check all of the dependencies for any vulnerability like bulletins for that version, right? So having something like that in your software, in your more traditional software development pipeline, this is kind of analogous to that with container images, right? Having that image scanning built into it. And so as you build new versions of the image, you push the image up to your registry, you scan it, and before it's made available for use for actually deploying things, right, there's a image scan done on it, right? And you do the common thing of, okay, we've got some high risk, things popping up, or medium risk. We have to manually go in and validate that and clear them, or remediate them, etc. So that involves all of the kind of baseline substrate of, here are the images, right? And here's the things we need to do to make sure our images are secure, which is, I guess, the building block, right? You think of that as like, that's sort of the foundation. And then we build up a little bit. So now we have images and we can use them, and we're doing things with those images within our cluster. So some of the things I like to see kind of with regards to the workloads in the cluster are logging and monitoring of all of the control plane calls. This is distinct from network monitoring. This is a feature built into Kubernetes itself that you do have to enable, but it allows you to log varying degrees of information about any of the API calls that are made to the Kubernetes API and the kubelet APIs, which are the heart and soul of Kubernetes, essentially. these APIs are exposed by the services that Kubernetes uses to actually, communicate with the container runtime and spin up, new resources or delete resources or pull information back about what's running in the cluster, so on and so forth. So those APIs are really powerful and very sensitive, right? So ideally, you want to look at what is being done, right? You want to maybe log and alert on authentication failures, right? Just like you might do, again, a lot of my background comes from web development as well. So, and web security. So, you may want to alert on authentication failures, right? Somebody's trying to log into this app a bunch of times and it's failing. Well, kind of the same thing with the Kubernetes API. What's going on here? Why is there a call to the exec endpoint, which allows for commands to be executed in running containers? Why is there a call happening a bunch of times to that's failing, right? That should flag an alert, and then you can go investigate. Maybe one of your services is, running into an error, or perhaps it's something malicious. And then kind of off of that, I mentioned namespaces. So namespaces are a really good tool for segmenting your workloads, right? So to give an example, to paint a picture here, let's say we have some CI/CD related services in our cluster somewhere. Jenkins is a popular one, right? And so Jenkins, it keys off of like maybe our internal Bitbucket repository or GitLab or GitHub, whatever it is you're using, right? New commit goes to a specific branch. And so that Jenkins instance that's running in the cluster pulls the code, runs some tests, builds it, and deploys a new containerized version of it to maybe like UAT or something, right? To a UAT namespace or a UAT cluster, right? So that you can go in and, your QA people can test the application, make sure it's good, do their checks. But then we have maybe a separate part of the cluster where the application itself is deployed, right? And this again could be a UAT version of it, or just some version that's exposed to the internet potentially. And that's where the application itself is running. Now, ideally, these different workloads are segmented off using different namespaces. One, just for organizational purposes, so that if things go wrong, the logs will tell you what namespace it originated from, things of that nature, right? So you'll be able to key in onto things much more quickly. But additionally, having, for example, maybe a app namespace and a CI/CD namespace will then allow you to implement additional security controls off of the namespacing. Because realistically, the app namespace, if we have the app exposed to the internet, well, now here's a potential way for an attacker into the cluster, right? The app could have some flaw that lets them get in and run commands. Well, now if they're going to do reconnaissance within the cluster, they may discover that CI/CD service. And for example, Jenkins is kind of notorious for being insecure by default. So they may discover that and start trying to attack it to try to pivot and, or anything of that nature. So the app namespace should not be able to talk to the CI/CD namespace. That just doesn't make sense. So because if you have proper namespacing, then you can use, for example, network policies, right? And network policies allow you to govern communications between pods, more specifically between networkable resources. But what this could do in this case is if you have your app namespace and your CI/CD namespace, you could then implement a network policy which prevents the app namespace and anything within the app namespace from issuing network communication to the CI/CD namespace, right? It could go the other way. The CI/CD namespace could deploy things into the app namespace, but the app namespace could not talk to that, right? So that's why it's very important, in my opinion, to, when you're designing your workloads, think about how they should be segmented off and then start implementing those namespaces. Because again, Kubernetes has some powerful security controls that operate off of namespaces. So if you don't have namespaces, you can't use network policies. They're going to be ineffective. But there's such a good security control that, you absolutely need to ensure that you're using them. And then kind of jumping, one step further, we kind of look at the runtime and network and sort of concept of roles within the cluster, right? So Kubernetes has the capability or the concept of pod security, and it's an admission controller. And what an admission controller is essentially a piece of software that runs in Kubernetes that determines whether or not some new resource is actually allowed to be admitted to the cluster. So if you were to have an admission controller that checked to make sure a deployment was using a signed image, then it would, validate the signature for the image and either allow the deployment to go through if the signature is valid, or block the deployment if the signature is invalid. So in the same vein, Kubernetes has a built-in admission controller, again, called pod security. It used to be called pod security policies. Some versions of Kubernetes, it's still going to be called that because while pod security policies are deprecated, it's a whole transition period of kind of phasing them out. Pod security has out of the box kind of easier to use levels of strictness, right? And so what these do, though, is these are policies that limit the capabilities of running containers. So they can restrict things such as what privileges does the container have? What kind of volume or file system mounts can the container have? What sort of Linux capabilities can it have? Can the process in it run as root or not? What user should the process run as? What images can be used, right? You can configure all of these details and apply that again to a namespace. And that will determine, right, that'll essentially check whether or not this container can be ran. So for example, kind of an anecdote, one of the things I would do on a pen test of Kubernetes is I will often try to deploy an evil pod, right? So I have a pod specification that I keep around that has, all the bad stuff, right, that I as an attacker would want to get. And so I'll go and I'll try to deploy it and determine kind of from that what security controls are maybe in place to prevent me from doing that. One of the things I often do is I will try to set up a bidirectional host mount, which effectively, if I can do that, that means I can manipulate files on the actual node server's file system, right? And that's bad. So pod security policies or pod security can restrict whether or not that is allowed. And so one of the things I kind of do is I check against that and see, is this cluster limiting what I can do? And so that's an example of sort of how that can, one way that can prevent an attack from actually succeeding. Additionally, we talked about logging a little bit on the previous section, right? We talked about logging API calls. Ideally, you should also log and monitor the cluster network traffic, right? And that's a little more intense, but it's definitely possible. You can implement, a common thing to do is implement what's called sidecar architecture to capture that traffic, capture traffic that, the network interfaces are generating, the services are generating, right? There's a lot of layers of granularity or specificity that you could really go through, but some degree of logging that traffic and monitoring it is important. For example, again, one of the things that attackers do, such as myself when I'm on a pen test, is if I get into a container, one of the things I will try to do is find some way to do network enumeration, right? So I'm going to start scanning the Kubernetes internal network to try to discover other services. And so that alone, right, could cause a flag, right? If you start seeing, SYN scans or something, right? That might mean that I somehow got Nmap into the cluster and I'm running an Nmap scan or something of that nature. Really quickly, that actually relates back to the pod security and limiting the capabilities of running containers. For example, one of the capabilities that a container can have is capped net raw, which allows the container to create raw sockets, which means that if an attacker could do that, then they could build out a SYN scan, right? Similar to how Nmap does it, and do that reconnaissance. But if the container does not have capped net raw, they would have to find a different way to try to do that reconnaissance. Most likely establishing like a full handshake with something. But anyways, that's getting into the weeds a little bit. So in addition to logging and monitoring that cluster network traffic, you also want to make use of role-based access control, right, and least permissions. So Kubernetes has two main authentication and authorization mechanisms. There is, I forget the name of it. It's like, I think, group-based maybe, or just straight up identity-based, I think. That is kind of bad. And for that reason, you actually won't see that being used in like the cloud provided versions, like AWS's EKS or Azure's AKS or GCP's GKE, Google Kubernetes Engine. They all by default implement or use the role-based access control, which is a configuration setting when deploying Kubernetes. And what that allows is for you to create roles within the cluster for various microservices, and even users can be bound to that if you have people like administrators or anything who need to be able to hop into the cluster from time to time or pull information back about the cluster. And so making sure those roles, have the least permissions that they can is quite a lot of work, but it's very important. But the role-based access control gives you a lot of granularity over that, so that you can create roles that can only do exactly what they need to do and nothing more. One thing that I see sometimes is there is a default service account in Kubernetes, and sometimes I will see additional permissions have been added to that service account, that default service account. That's risky because every container that's ran within the cluster will get that default service account assigned to it if one is not assigned to it when deployed, right? So if you don't specifically assign it a service account, it'll just get the default service account. So if that has additional permissions assigned to it, right, well, now there's this potential avenue to compromise one of those services and leverage that service's service account to elevate privileges or pivot within the cluster. And so keeping the default service account very minimal is important. I would advise against changing it at all, because by default, it's very restricted. Create specific service accounts, create specific cluster roles for tasks that need to be done, right? Let's jump to the next slide. So getting into just some more kind of high-level tips here, right? Label and annotate cluster resources. This is the thing you can do when building them out, right? You can create arbitrary labels that are essentially just metadata on these cluster resources. One good thing to do is to label essentially like what team or what department or what project even is this a part of, right? So that way, when you're looking at logs and pulling back information after the fact, it's easy to identify who the responsible party for that resource should be, right? Even if it's something is just broken, right? It'll be, you encounter downtime, you want to find the responsible party for that service quickly, right? So having that rather than having to necessarily jump through a bunch of hoops of, who, playing, who's who or whatever with that resource, trying to figure out, what team or what developer is responsible for it. That also can kind of potentially create, if you see resources that are not labeled, right, you may consider those anomalous, right? And so then it becomes an incident at that point, right? To investigate, to see, well, why do we have this unlabeled, pod or this unlabeled container running, right? Let's look into that and see what's going on here, right? Because it could be something malicious. Make anonymous authentication is disabled. This is also one you'll, like, by default, you'll see disabled in the cloud provided Kubernetes services. But Kubernetes does have an anonymous service account, if you will, and it can pull back some limited information about the cluster. You ideally want to disable that just so that there's no information that can be pulled back about the cluster without some kind of valid credentials. There was a time in which there was a vulnerability a while back where the Kubernetes internal proxy was vulnerable, and you could make a request to it as anonymous, as using the anonymous authentication, and then the proxy itself would reach out to some other services, but the proxy itself had a service account associated with it that was highly permissioned. So there was a way to get the proxy service to essentially escalate your privileges within the cluster. So if that is enabled, or you're managing your own cluster by default, you're deploying your own cluster, make sure that that's disabled. Ensure that access to the Kubernetes and kubelet APIs is secure, right? That means making sure that they're running over HTTPS, provisioning valid certificates for them. I see a lot of Kubernetes deployments using self-signed certificates, and while it's not necessarily immediately that bad, right? It's not the best practice. Provision a certificate using your own CA authority. One example I see that comes up a lot that I personally don't like is Google Kubernetes Engine exposes the master node, which runs the Kubernetes API. So that's exposed to the internet by default, and you have to enable an identity-aware proxy on top of that, so that because otherwise, just anybody can access that endpoint. And it does have authentication on it, but it's still, right, that is still attack surface that's now exposed. Whereas there is a feature to enable a proxy that is identity aware, so you can manage who can access that API using something like Google Groups, right? So having sort of federated identity management for your users, your actual people, for accessing your cluster is very important. Encrypt your secrets at rest. By default, Kubernetes does not encrypt secrets. And so it has the notion of secrets, which are, for example, those service accounts I keep mentioning. The way those work is there is a JSON web token that's generated and stored in the cluster as a part of, right, the secret. There's certificates stored within secrets in the cluster. And by default, that information is not encrypted. You do have to have, for example, a service account that has permission to read them, but it's not encrypted. And so if an attacker were able to get, maybe sniff the traffic in some way, or get access to one of the host systems that's, storing the secrets, they're going to be able to read them, right? So there are solutions to do that. Most of those are going to be like third-party integrations to manage the secrets. A popular one I know of is HashiCorp has one called Vault, which integrates and can manage your Kubernetes secrets. But it's important to make sure that those are encrypted at rest. Okay. So here's just a list of some kind of vulnerability detection solutions to be aware of, right? So there's Kubernetes-native things. And I put this here just to show you kind of like, here are things that Kubernetes itself does have that can help you kind of detect things. and prevent things, but you would have to, have some manner to key off of and alert off of those, which I'm sure we all know logging is very difficult to do properly, and requires a lot of effort on its own. But there are other kube control audit logs. That's the API control plane I mentioned. A lot of what an attacker is going to do within a cluster is going to be trying to abuse service accounts to try to pivot or elevate their privileges using the Kubernetes API, right? So there's going to be a lot of signs in those logs, essentially, right? That an attack is happening or has happened. Pod security policies, right? If an attacker gets a hold of some credentials, you can prevent them from being able to deploy, the kind of container that they would want, because a lot of times what the goal is going to be is to try to escape or compromise the actual node or the cluster itself, right? So you can prevent them from being able to do things like the bind mounts or run privileged containers or run them with certain permissions or capabilities. So it's important to kind of have that there. That again can come in and sort of save the day. And then we have just general admission controllers. There's admission controllers, for example, to validate image signatures, as I mentioned before. You could, in theory, have an admission controller that does really whatever you want because it's a generalized piece of software. And so you could have an admission controller that checks whether or not an image is using vulnerable dependencies, right? That they're out of date. And if they are, reject that deployment. Could be one way to do that and flag it. But there are a lot of third-party integrations that typically deploy to the cluster, right? So there's Trivy, there's Anchor Engine, there's Sysdig, Falco, there's Twistlock. Twistlock's really good. Snyk has some stuff. There's Claire. JFrog has a solution. StackRox, and I think even Nessus, like Tenable, has some Kubernetes related stuff. So there's a lot of solutions, and I recommend, right? These are kind of the Kubernetes native stuff, or things you should be doing anyways, and thinking about. But you should also definitely consider the third-party solutions. And when you look at a third-party solution, right, a lot of the things I've discussed here with the third-party solutions are things that you would want to be evaluating that solution for, right? Does it provide these sort of baseline, high-level, security practices, right? How is it fitting within these things that we just talked about? Okay, so let's talk about the CIS benchmarks real quick. So the CIS benchmarks, this is not all of the benchmarks from it, but these are the ones that I think are kind of the main ones that you'll be looking at if you go through those, the ones that are going to be the most actionable, I think. Right? Again, we talk about API server configurations, right? This is what I talked about just a minute ago, securing those API servers, the kubelet API and the Kubernetes API, right? Making sure that they have encrypted communication. You can do client authentication as well, which means when a node or something wants to talk to that API, it has to present a certificate that's validated. etcd. So by default, Kubernetes uses the etcd to store secrets and config information like certificates and things of that nature, right? So there's a whole degree of security checks that have to go into making sure that service itself, which runs on one of the nodes, whatever the Kubernetes master node is, making sure that it's secured, right? That's especially important if you're deploying Kubernetes yourself, right? Kubelet configurations, these not only does the API have, right, configurations for encryption, there's also additional configurations that it has and what it can do, what it's capable of, things like that. And that's the service that runs on the worker nodes. RBAC and service accounts, right? We talked a lot about that. The CIS benchmarks go into that a lot. Network policies, I talked about those. This is a big one. That's a really good security control. Logging and monitoring, again, it's hard to do. but it's very important. Pod security policies. The CIS benchmarks do talk about pod security policies, and I think I'd have to check. I don't know if it's updated yet to talk about pod security, which it's confusing the way they named it, where the Kubernetes group decided to do this, because they deprecated pod security policies, and then they called the new thing pod security, but it's also policy based because you define policies for it. So then would you call those pod security policies? It's confusing. But they do sort of similar things, so it's important, right, to look into that guidance there. And secrets management, right? Again, maintaining access policies, what roles are allowed to access the Kubernetes secrets, and encrypting them, right, at rest. It goes into a lot of details on how to do that as well. All right, so really quickly, I'm gonna share my screen and we're gonna go through a little demo. How do I share my screen? Where's that at? Share content, screen. Now let's do. All right, I hope you can see this well enough. Let me see, I might want to make it just a little bit bigger. Okay, so in this demo, what we're going to do is I'm using a project called Kubernetes Goat. And it's a nice little project that basically has a couple of scenarios going on that you can work through. And so you deploy this Kubernetes Goat to a Kubernetes cluster, and it runs vulnerable services and things like that. Well, one of the scenarios it has is actually a scenario in which we can use Kubernetes bench. So if we look at the scenarios real quick, we can actually see there's this kube bench security folder in here. And what that has, is two jobs in here. It has this master job and this node job.yaml. And I'm actually I can show you one of those really quickly. If I can operate my terminal, we'll do the master job, right? And so we've got this YAML file here, and this is a Kubernetes batch job, which is a type of resource that Kubernetes supports. And it's meant to, right, essentially allow you to script and operate, create jobs that should run one or however many times within the cluster. It's not necessarily a service that you're going to want to expose or have running constantly, but it is still a workload that you need to have happen in the cluster, right? And so, and it specifies what containers to run. So the way KubeBench works is you deploy it to your cluster, and it, deploys with quite a few, privileges so that it can scan the cluster and do checks against the CIS benchmarks, right? So you see it's got all these volumes that it's mounting. For example, I just mentioned etcd, right? So on the master node, it's going to mount the etcd volume from the host master node into the container so that KubeBench can then check things about that directory and configure those configuration files. Right? So there's a good bit here. So I'm going to quit that. So the way we would run that is, in my case here, you get pods. You can see I actually ran it once already, and it completed. That was just me making sure that it was going to work. But we can just do control apply tac f scenarios kube bench security, and I'll do the master node one. And so we'll run that and kube control, or I might need to remove it first actually. So let me do that. Kube control get jobs. Yeah, I'm gonna remove it first. Because I think it's not, since the file didn't change, it's not gonna run it again necessarily. So let me do kube control delete job kube bench master. So we should be able to delete that, and then so it's gone now. Clear that, and then what I'll do is I'm going to go back up and I'm going to apply that job again. And should see that it's currently running, right? And we can watch this. So it's going to run, and it completed. It didn't take very long at all, right? It took 9 seconds roughly. So the way we can view the results of this is, I mentioned Kubernetes has logs, and it logs a lot of things. Well, one of the things it also keeps track of is the standard out and standard error of containers. So this job created a container, right? It created a pod, which we can see if we do get pods, we can see Kubebench master pod here. That's what that job used to run Kubebench. I'm going to copy that, and I'm going to do kube control logs, and I'm going to just paste. Oops, maybe not. Paste isn't going to work. Yeah, there we go. I'm going to paste the name of that pod, right? And so we get a bunch of stuff out here, right? So just to make this a little easier, I'm going to probably like kb.text, pipe it to that, and we'll open it up in a text editor. And so there's a bunch of information in here. And what this just does is the first bit of it just summarizes each of the checks it ran, right? And these map, like this 1.1.1, right, whatever, this maps to a section of the CIS benchmark, the Kubernetes CIS benchmark specifically, right? So it's doing these checks based on that, right? And it reports what failed. Some of these are warning, right? Like ensure the container network interface file permissions are set to 600 or more. But one nice thing about this too is if we jump down to the end, we get the little summary here, right? Nothing passed. We got 46 failures. This cluster is not very secure. But if we look at these, so each of these map to these sections, well, down here it also provides suggestions on how to fix the issue, right? So, right, like this one, whatever 1.2.15 is, follow the Kubernetes documentation and configure node restriction plugins on kubelets, right? And then edit the pod specification, so on and so forth, right? So it definitely is very useful information here, because it doesn't just say like, oh, something's wrong, right? Figure it out. It also provides some guidance on like where you should look in the benchmarks. So you have that, so you can go look, get a deeper dive in the problem. And also it's providing, right, in many cases, recommendations on how to fix the issue. Yeah, and so for example, this file permissions issue, which shows up a lot, right? This it's just saying run this command, right? So chmod 600 on this kube API server.yaml file, right? So it's totally reasonable to, I mean, Kubernetes is entirely API driven, so it's totally reasonable to like automate against this. And there are tools that will do that as well. But I just wanted to show you an example of, right, really just digging in real quick, using the command line to run this tool and looking at the results. But this is all parsable. You can actually have Kubebench output this in like JSON as well, or other formats, so that, you know, you could consume it programmatically and, you know, log it elsewhere. I'm going to switch back to the slides real quick, because we are coming up on time, and I'm almost done. I just wanted to mention that at the end of the slides, which you'll have a copy as a handout, but I did list some resources here. A couple of scanning tools, KubeScan. We already talked about Kubebench, KubeHunter. That KubeHunter is a little more blue team threat modeling / red teaming, right? Twistlock / Prisma Cloud, which I think is what it's called now, is honestly a really good solution. The times I've done a pen test where that was deployed, it pretty much kicked my butt. So that is definitely worth looking into, in my opinion. There's, of course, the CIS benchmarks. The NSA put out a Kubernetes hardening guide at one point. Kubernetes documentation itself actually has a really good section on securing your cluster as well. Honestly, the Kubernetes documentation is just really good, even if it's a little hard to navigate. And OWASP actually put out a Kubernetes security cheat sheet as well. And then a little shameless self-plug here. Nathan mentioned some of my courses at the beginning, but I do have 3 courses. One of them is coming up soon, which is the out of the box strategies for escaping containers, but the others are happening later this year as well. So I've got these 3 classes. One is where I will walk through how to pen test a Kubernetes cluster. One is walking through how to escape from containers. And then the other one is actually how to harden and defend a Kubernetes cluster, which I think that's probably my favorite one, because we're going to take a vulnerable cluster and we're just going to go through like fixing it essentially, right? Just figuring out what's wrong with it, why it's insecure, and remediating some of that, and talking about those high level strategies in more depth. So a lot of the stuff I talked about here really quickly, there will be that, I'll be doing a deep dive into a lot of that in the Fortress Kubernetes class. But yeah, that's it. Thank you so much for your time. And I'm going to hand it back over to Nathan so that he can say any last words or whatever he needs to do.
Awesome. Well, great job, Cory. And as he mentioned, I provided a link earlier for one of the courses, and I didn't scroll down enough to see the other 2. So I'm going to go ahead and repost those there. There's the first one. That's the strategy for escaping containers. That is on September 13th. The second one, Kubernetes under siege, mastering penetration testing techniques, that is on November 1st. There's a link for that. And then the third one, a comprehensive guide to defending and hardening Kubernetes. So if you're more on the defensive side, this one on November 29th might be useful for you as well. The other thing, just in case anybody missed it, in addition to the references and resources he has listed on this slide, I also linked to KubeBench and Kubernetes Goat, which he used for that demo. So if you're wanting to say, hey, how do I find those? Obviously, you can Google it for yourself, but I provided the links there for help. As we mentioned, the handouts are available in the handout section in the top right. If you want to click that and get access to that, you can get the slides. And then I mentioned earlier, but if you joined late, if you need a CPE, shoot that over to education@securideas.com and just ask for a CPE document for this, and we'll shoot that over to you. The last thing I wanted to mention one more time is upcoming webcasts. You can access those at securideas.com/webcast. There's the link. We've got one coming up in September 14th. So it's about 2 weeks out on defending cloud security, some critical controls there for different cloud security vendors that you'll want to be aware of. And then a conversation about preventing ransomware, more than just backup and recover, but some different options and stuff you can do on September 22nd. So thank you, everybody, for your time. Cory, thank you. Great job. You must have
No problem.
You must have sacrificed to the demo gods because everything went smoothly. No problems at all.
I did. I did also record it just in case. So.
Just in case backup. Yeah. It's always good to have a backup to your backup. So yeah. Great job. Everybody have a great afternoon, and we'll see you next time.
Take care, everyone. Thank you for your time.
Thanks.